ਸਟਾਰਟਿੰਗ ਮੋਟਰ ਹੈ ਇਹਨੂੰ ਕੱਟ ਆਫ ਕਰ ਦਿੰਦੇ ਨੇ ਤੇ ਆ ਨਾਲ ਹੀ ਜਿਹੜਾ ਟਰਬਾਈਨ ਦੇ ਜਨਰੇਟਰ ਕਪਲ ਕੀਤਾ ਹੋਇਆ ਇਹ ਪਾਵਰ ਜਨਰੇਟ ਕਰਦਾ ਹੈ। ਆ ਜਿਹੜਾ ਹੈਗੇ ਹੈ ਇਹ ਉਹ ਜਿਹੜੀ ਐਗਜ਼ਾਸਟ ਗੈਸਿਸ ਨੇ ਉਹਨਾਂ ਦੀ એનર્ਜੀ ਜਿਹੜੀ ਹੈਗੀ ਯੂਜ਼ ਕਰਨ ਵਾਸਤੇ ਆਪਾਂ ਇਹ ਇਕੋਨੋਮਾਈਜ਼ਰ ਲਾਏ ਹੋਏ ਨੇ। ਇਨ ਦਿਸ ਟਾਈਪ ਆਫ ਟਰਬਾਈਨ combustion of fuel take place at constant volume. Figure shows the principle of constant volume gas turbines. ਹੁਣ ਇਸੇ ਸਕੈਚ ਨੂੰ ਮੈਂ ਅਗਲੀ ਸਲਾਈਡਾਂ ਦੇ ਵਿੱਚ ਡਿਟੇਲ 'ਚ ਐਕਸਪਲੇਨ ਕਰਾਂਗਾ। ਪਹਿਲਾ ਹੈ the air drawn from the atmosphere and compressed in the compressor to a pressure of 1.5 to 3.5 bar and force into the combustion chamber CC through valves V1 and V2. The oil which is stored in the fuel tank is pumped to the combustion chamber through the valve V3 when V1 and V2 are closed by means of pump P. After the work, the valve V3 is also closed and the oil is ignited in the presence of air by spark plug SP. The ignition takes place at constant volume resulting in an explosion, and during this process pressure rises to 10 bar. मतलब ਕੀ ਹੈ ਆਹ ਜਿਹੜੇ ਮੈਂ ਅੱਗੇ ਐਕਸਪਲੇਨ ਕੀਤੇ ਨੇ ਆਹ ਵਾਲਵ ਨੇ ਆਹ ਵਾਲ ਜਿਹੜਾ ਹੈਗਾ V3 ਹੈ ਆਹ ਵਾਲ V1 ਹੈ ਆਹ ਵਾਲ V2 ਹੈ। This opens up the nozzle valve NV। ਜਦੋਂ ਐਕਸਪਲੋਜ਼ਨ ਹੋ ਜਾਂਦਾ ਹੈ ਉਸ ਤੋਂ ਬਾਅਦ ਕੀ ਹੁੰਦਾ ਹੈ this opens up the nozzle valve NV through which the product of combustion flow which passing through nozzle valve NV the pressure of the gaseous product of combustion drops, but there is considerable increase in velocity. As the high velocity gases flow over the rings of moving blades of the turbine, their velocity drops, imparting a rotary motion to the impulse turbine rotor shaft. The nozzle valve remains open till the products of combustion from the combustion chamber are exhausted. The rotor blades, nozzle and combustion chamber are cooled by water jacket. The exhaust gases from the turbine pass through heat exchanger H, which convert the hot water from jacket into steam, which in turn run the steam turbine coupled with the compressor C. The motor M is operated at time of starting only. Disadvantages ਇਹਦੇ constant volume gas turbine ਦੇ ਨੁਕਸਾਨ ਕੀ ਨੇ? Speed of rotation is not continuous, means intermittent. A number of valves are there outdated. Next ਹੈਗੀ ਹੈ ਆਪਣੀ ਸੈਕਿੰਡ ਟਾਈਪ constant pressure gas turbine ਜਾਂ ਇਹਨੂੰ ਕਹਿੰਦੇ ਨੇ continuous combustion type gas turbine. It is also called continuous combustion type gas turbine because the combustion of fuel takes place at continuously. It works on the Joule cycle. In figure B, आड़ी figure थले दी हुई है, figure B है, shows the working of the turbine. Atmospheric air is drawn and compressed by the compressor C, which is usually driven by turbine rotor shaft to pressure of 1.5 to 4 bar. ਆਹ ਜਿਹੜੀ ਹੈਗੀ ਹੈ ਵਰਕਿੰਗ ਸਕੈਚ ਹੈਗਾ ਕਾਂਸਟੈਂਟ ਪ੍ਰੈਸ਼ਰ ਗੈਸ ਟਰਬਾਈਨ ਦਾ। ਆਹ ਜਿਹੜੀ ਇੱਥੋਂ ਦੀ 에ਅਰ ਇਨਟੇਕ ਹੁੰਦੀ ਹੈ ਕੰਪਰੈਸਰ ਜਿਹੜਾ ਕੰਪਰੈਸਰ ਜਿਹਨੂੰ ਕੰਪਰੈਸ ਕਰਦਾ ਹੈ। ਆਹ ਜਿਹੜੀ ਹੈਗੀ ਹੈ ਆਪਣੇ ਸਟਾਰਟਿੰਗ ਮੋਟਰ ਹੈ। ਆ ਸਟਾਰਟਿੰਗ ਮੋਟਰ ਜਿਹੜੀ ਹੈ ਉਹ ਕੰਪਰੈਸਰ ਨੂੰ ਰਨ ਕਰਨ ਦੇ ਵਿੱਚ ਕੰਮ ਆਉਂਦੀ ਹੈ ਅਤੇ ਉਸ ਤੋਂ ਬਾਅਦ ਟਰਬਾਈਨ ਨੂੰ ਵੀ ਫੁੱਲ ਸਪੀਡ ਦੇ ਵਿੱਚ ਰਨਿੰਗ ਵਿੱਚ ਕੰਮ ਆਉਂਦੀ ਹੈ। This high pressure air is then supplied to the combustion chamber where it splits into two parts. Some of air enter the burner B and is consumed during the combustion of oil, while the remaining air flows through the annual space AA between the walls of combustion chamber and mixing chamber. This hot air then meets and mixed with the hot gases from the burner. The temperature of these outcoming gases is very high and may cause damage to the blades of turbine. This temperature is controlled by supplying excess air from compressor. Then the mixture is allowed to expand over the blades of turbine T, continuously imparting rotary motion to turbine T. The gases leave the turbine at atmospheric pressure. The turbine drives the compressor C and generator G. The parts of turbine output used to run compressor is called back work. The compressor used 75% of power developed, while 25% remaining is used to run the generator G. The motor M is used for starting the turbine. In case the pressure of hot gases to the turbine become excessively, the safety valve B opens. Next ਆਪਾਂ ਗੈਸ ਟਰਬਾਈਨਸ ਨੂੰ ਫਰਦਰ ਕਲਾਸੀਫਾਈ ਕਰ ਸਕਦੇ ਹਾਂ, ਚਾਹੇ ਉਹ ਕਾਂਸਟੈਂਟ ਵੋਲੀਅਮ ਗੈਸ ਟਰਬਾਈਨਸ ਹੋਣ, ਚਾਹੇ ਕਾਂਸਟੈਂਟ ਪ੍ਰੈਸ਼ਰ ਗੈਸ ਟਰਬਾਈਨਸ ਨੇ। ਉਹਨਾਂ 'ਚ ਪਹਿਲੀ ਕੈਟਾਗਰੀ ਹੈ ਓਪਨ ਸਾਈਕਲ। ਆਹ ਓਪਨ ਸਾਈਕਲ ਦਾ ਸਕੈਚ ਹੈ। ਦਿਸ ਇਜ਼ C ਇਜ਼ ਕੰਪਰੈਸਰ, T ਟਰਬਾਈਨ, E ਹੀਟ ਐਕਸਚੇਂਜਰ, C ਕੰਬਸਸ਼ਨ ਚੈਂਬਰ, ਆਹ ਐਗਜ਼ਾਸਟ ਹੈ। The temperature of exhaust gases leaving the turbine is very high, much higher than that of the air discharged from the compressor. ਹੁਣ ਓਪਨ ਸਾਈਕਲ ਦਾ ਮਤਲਬ ਕੀ ਹੈ ਵੀ ਟਰਬਾਈਨ ਨੇ ਆਪਣਾ ਕੰਮ ਕੀਤਾ, ਐਗਜ਼ਾਸਟ ਗੈਸਿਸ ਜਿਹੜੀਆਂ ਨੇ ਉਹ ਬਾਹਰ ਆ ਗਈਆਂ, ਉਹਨਾਂ ਦੀ ਆਪਾਂ ਜਿਹੜੀ ਐਨਰਜੀ ਹੈ ਥਰੂ ਹੀਟ ਐਕਸਚੇਂਜਰ ਜਿਹੜੀ ਹੈ ਆਪਾਂ ਇਸਤੇਮਾਲ ਕਰ ਲੈਂਦੇ ਹਾਂ, ਅਤੇ ਉਹ ਜਿਹੜੀ ਐਨਰਜੀ ਹੈ ਉਹ ਆਪਾਂ ਕੰਬਸਸ਼ਨ ਚੈਂਬਰ ਨੂੰ ਦਿੰਦੇ ਹਾਂ ਤਾਂ ਜੋ ਉੱਥੇ ਫਿਊਲ ਦੀ ਘੱਟ ਵਰਤੋਂ ਹੋਵੇ। ਇਹਦੇ ਵਿੱਚ ਪਹਿਲਾ ਹੈ ਯੂਜ਼ਿਸ ਆਫ ਹੀਟ ਐਕਸਚੇਂਜਰ। ਦ ਟੈਂਪਰੇਚਰ ਆਫ ਐਗਜ਼ਾਸਟ ਗੈਸਿਸ ਲੀਵਿੰਗ ਦ ਟਰਬਾਈਨ ਇਜ਼ ਵੈਰੀ ਹਾਈ, much higher than that of the air discharged from the compressor. This losing energy can be recovered by imparting a heat exchanger which increases the temperature of the compressed air before entering the turbine. Open cycle gas turbine plant has the disadvantage of lower energy per kg of the gas. Due to lower density of the working medium, a large air is required. The air is about 10 times that of the steam flow in a steam power plant of the same output. The maximum capacity of open cycle gas turbine plant is 15 megawatt to 22 megawatt. These problems are rectified up to some extent in closed cycle gas turbines. On next है closed cycle gas turbines. Here a pre-cooler is employed before the air enters the compressor. The compressed air after passing through the heat exchanger is led to the heater H. This is heater H, where heat is supplied to air by fuel. The hot air after passing through the turbine is passed through heat exchanger and then through pre-cooler X, and this is the pre-cooler X. Thus the same air remains continuously in circulation through the plant. Next है helium versus air as working medium. Though air has been extensively used for closed cycle gas turbines in recent years, though the use of helium being lower in density has been inviting the attention of the manufacturers of larger output gas turbines. The specific heat of helium is about 5 times that of air. Therefore, the energy dealt with in the helium machines about 5 times more than that of air machines. Means helium ਨੂੰ ਵੀ air ਦੀ ਥਾਂ ਤੇ as a working fluid in case of gas turbine ਇਸਤੇਮਾਲ ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ, ਕਿਉਂਕਿ ਉਹਦੀ ਸਪੈਸੀਫਿਕ ਹੀਟ ਹੀਲੀਅਮ ਦੀ 에ਅਰ ਦੇ ਨਾਲੋਂ 5 ਗੁਣਾ ਜ਼ਿਆਦਾ ਹੁੰਦੀ ਹੈ, ਜਿਸੇ ਕਰਕੇ ਉਹ ਸਪੈਸੀਫਿਕ ਹੀਟ ਜ਼ਿਆਦਾ ਹੋਣ ਨਾਲ ਉਹ 에ਅਰ ਦੇ ਨਾਲੋਂ 5 ਗੁਣਾ ਜ਼ਿਆਦਾ એનર્ਜੀ ਸਟੋਰ ਕਰ ਸਕਦਾ ਹੈ. For an equal percentage of loss of energy within turbine work, the velocity of helium corresponds to 2.2 times that of air. The surface area of heat exchanger for helium can be kept as low as the working medium. For the same temperature ratio and for the plants of the same output, the cross-sectional area required for helium is much less than that of air. Thus, we conclude that the size of helium unit is considerably small. Since the heating is external, the product of combustion do not mix with the working fluid. Any fuel of high calorific value may be used. There is no corrosion and accumulation of deposit of carbon or tar on the blades and nozzles of the turbine. There is no necessity of internal cleaning. The air is pre-cooled in the pre-cooler before entering the compressor. Consequently, the specific volume of air decreases. Hence, for a given output, the size of compressor and turbines are very small. As the cycle is reversible one, it has higher thermal efficiency. By making an inert gases like lithium as the working medium, the materials like molybdenum alloys can be used for turbine design. Fuels ਕਿਹੜੇ fuels ਆਪਾਂ ਗੈਸ ਟਰਬਾਈਨ ਯੂਜ਼ ਕਰ ਸਕਦੇ ਹਾਂ? ਕੈਰੋਸਿਨ, ਜੈਟ ਫਿਊਲ, ਪ੍ਰੋਪੇਨ, natural gas. Advantages of closed cycle gas turbine. Since the heating is external, that is the product of combustion do not mix with the working fluid. Any fluid of high calorific value may be used. There is no corrosion and accumulation of deposit of carbon or tar on the blades and nozzles of the turbine. The air is pre-cooled in the pre-cooler before entering the compressor. Consequently, the specific volume of air decreases. Hence, for a given output, the size of compressor and the turbine are very small. As the cycle is reversible one, it has higher thermal efficiency. By making an inert gas like helium as the working fluid, material like molybdenum alloys can be used for turbine design. The waste of heat of combustion gases from the heater and reheaters can be further used for heating water, and which together with the hot gas water from pre-cooler and intercooler can be utilized for hot water supply for industrial purposes.